And we are recording. Welcome everyone to another Integration Quest MuleSoft study group. We're going to be going over the power of MUnit mocking today. Ryan's going to be taking care of that and going through it with us. So we're going to go ahead and go over a couple things real quick that I show before we turn it over to him. The first thing is just real simple. No issues as of late, but we just got to say, if your mom and dad would have told you not to do it, please don't do it, and everything will be great. I've been going over how to time travel with Integration Quest. You can do some time traveling. You can go over to not just YouTube, but also to the Integration Quest website. There's the two links right there. And you can find all of our archived study groups. So if you missed a study group, no problem. We got you covered. You can go to any one of those two spots and check out some really, really good information, lots of knowledge. I recommend you subscribing while you're at YouTube, because then you'll get that little notification that we just dropped another video for you. So hop in your time machine, go over and check it out. Today we've got Ryan here. I probably don't need to do much of an intro because mostly everybody knows what he is and what he's all about and what kind of certificates, everything that he's got. But I just wanted to go ahead and go over it and just let y'all know that he has been doing this since I was in diapers. I'm just kidding. Ryan and I are actually we are actually the same age. We just found out, or close to it. I think we were off by like 3 or 4 years.
Yeah.
And he started doing this when he was 17, and he's been doing it for a long time.
Not MuleSoft.
Well, obviously not MuleSoft, but he's been in IT that long, and 15 years with the MuleSoft. And it's just when I see stuff like that, it's time to just like, all right, let's be quiet and let's learn something. So that's what I'm going to be doing today. I'm going to be learning about MUnit mocking, obviously, and I just wanted to intro him and bring him in and have everybody give him a nice warm welcome. I'm going to stop sharing and let him take over so that way he can do that.
All right. Hi, guys. Thanks for the warm intro. I think it's not about how long you've been doing it as much as it's about the love for it. I had breakfast with a guy today, and he's been doing it since he was a minor, as like I was.
Awesome,
and there's something about I brought up the word vocation because it's different than occupation, isn't it? Like, this software is a vocation for me because like I don't I'm not charging anybody for this time, right? There's something more to this vocation that we have about software than just only making money. I think. Right. And I don't judge anybody who's here to make a buck, but I really do believe in capitalism, and that mostly money follows value. And what is value? Value is something, it's like service. It's something you do for someone else, right? So software is a way to do more for other people.
I agree. I've always said, if I'm doing something for the money, I'm in the wrong place, because I've never done anything for a lot of money. Like it just never was there.
Well, but I do think if we do this well, it can it can be that you're entrusted with more in order to accomplish more, right?
Yep.
And then you got to then it's our job to be responsible with that. This slide I brought up is not for the study group. I had the wrong presentation up. This is the title slide from a MUnit class that we taught last year, and we're shaping it up for a new class this year about MUnit. So it's this is actually one of the sessions from one of the sessions in the class, and I was pulling together material from our actual real paid class for MUnit for this particular study group. But this is the specially created study group version of this, and I guess this is a topic that's bigger than just MuleSoft. This is about the vocation of software, about making computers do what we want them to do. Computers do the right thing. So what's the right thing, right? How do you know what the right thing is in a piece of software? I'm using silence as a way to get you thinking, right? How do you know what the right thing is? Well, a test can express the right thing, right? So we can use tests in software to tell the computer what the software should do, right? Not what to do. You understand, like, code is like instructions. I'm going to tell the computer what to do. The test is different. It's not instructions. The test is telling the computer what the right answer is. It's telling the computer what outcome we want, right? So they're complementary. They're two different things, right? So MUnit's a way in Mule to tell Mule what we want the code to accomplish, right? And in a very specific way. So this is a lesson on test isolation. Now, I didn't make up the idea of test isolation. Test isolation comes from a long history of thought in software about the way to write tests as specifications, not just as verifications. I want you to think of the vocabulary there. Like a test can verify something. Sure, of course it can do that. But that's missing out on all the value of testing. Tests specify something. And think of a specification is specific, right? A specification means I am being extremely clear about what I want. There's intention in a specification. So you can be pretty clear in natural language. You can be way more clear using code. So an MUnit test specifies very precisely what I want a Mule application to do for me, what I want integration to do, right? And then the application either does or does not do it. So isolation is a practice that we use to make sure that we are expressing what we want a particular unit of code to do. MUnit is called unit because the word unit is there because we're identifying a particular part of our code, not all of the code in play. Like in an integration, there's your integration logic and there's whatever it's plugging into. And I'm trying to specify what my integration logic is supposed to do, not what the whole system does. Just this part. I want to make this part do something. In order to do that, I need to isolate this part somehow. Somehow I need to tell the computer that only this part is being checked at the moment, not all of the other things it's plugged into, right? Not Salesforce, not the database, not the FTP server, not even another API. I just want to check this one little thing. So I have to have a way to precisely specify what is this one little thing. And that's what test isolation is all about. It's a practice. It's a design practice of intentionally drawing boundaries around part of your software system. So I have to have not only a way to think of what those boundaries are, but a way to directly express that to my testing code. And that's what test isolation is all about. That's what this study group's about today. So test isolation can have different strategies of test isolation. So I took this from Martin Fowler's Blicky. You see the little link at the bottom, and I'm old school. I'm not giving you a QR code this time. So you can go type it into Google or something. Martin Fowler does have quite a bit of useful stuff to say about software design. He's been writing on this thing he calls his Blicky for decades, right? So I'm going to try to answer your question. Feng wrote a question in the chat. What's the difference between test isolation versus unit tests? And that's a nice, I guess this is the perfect slide for it, right? So a unit test is a particular thing you want to check about the system. So first of all, the word unit, it identifies a unit of code. Like this is what I'm going to run. This is the input and this is the expected output. That's the unit test, right? That all that information together. You have to have a way to express the input, what to run, and then what the output should be. Test isolation is the practice of how you determine what code runs on step 2. So I only want this code to run and not that other code, right? So I have a design choice to make about how much to isolate, right? So I could isolate the code that I'm testing along with some of its dependencies. That's why all these are brown on the left side, right? A sociable test, this is Martin Fowler's vocabulary. A sociable test is one that includes some of its dependencies. Not only do I want to make sure my code does the right thing, I want to make sure my code with Mule 4.9 and a Windows server on-prem in a cluster, like I'm including some of the context of my code in what I'm testing on purpose. So both of these types of these strategies of test isolation are strategies you adopt on purpose. So, and in your integration, you're going to have a good use for some sociable tests and some solitary tests. So I don't agree with Martin so much on the right side comment. He said some unit testers prefer to isolate the tested unit. So I believe we've moved past the point of this being a stylistic choice. I approach test isolation more as an engineering discipline that we have clear better ways and worse ways to do it for different purposes. It's not just a matter of preference or style, right? So some types of tests work really well as sociable tests, so not a lot of mocking. I'll give you a good example of one. If you build a health check for your application and its job is to go check all the, maybe it's an experience API, and I want to make sure that it checks the process APIs and they check the system APIs and those check the underlying systems. That test is intended to check the whole system put together. That would, you might even call it an integration test or a functional test. So there's different types of tests that you write, and they're all unit tests because they all measure some unit of software, right? But some of the units you want to test are composite. They're many components all wired together. And I want to make sure that when they're all wired together, that whole unit works. That would be, you could call that an integration test. Some of the vocabulary there is debated by people. So I like the term sociable because it's not taking a position of how much is brown on the diagram, right? It's just that sometimes there are useful tests to write where dependencies are included in the test, in the code that's being tested, right? And those would be sociable tests. There are a lot more tests that are going to be valuable because we don't include the dependencies. Those are the solitary tests. And I do mean more in terms of numerous. So in a system, you're not going to need so many tests for everything plugged into each other. One or two are going to be fine, right? But you're going to need a lot of tests for each of the little pieces if you're checking them independently, right? So most of the tests we end up writing in an integration application, most of the unit tests are going to end up being solitary tests just because there's more pieces to be tested, right? There's more units that need testing when you do solitary tests than there are when you do sociable tests, right? So we're going to use mocking some for sociable tests, and we're going to use mocking a whole lot for solitary tests. And I'm going to get into how you actually do mocking. So that's just a distinction I want to make, right? The design of your test isolation has to do with what software belongs in scope for the experiment I'm running, for the test that I'm creating here. So this is a test design idea rather than an implementation idea. All right, so why am I isolating? There's a few reasons to isolate the test. And I want you to be thinking of the scientific method here. A test has a lot in common with an experiment, right? I have a hypothesis, and the hypothesis is that the code does work the way I would like it to work, right? But I need to run an experiment to see if it really does, right? So one thing I need to do is control the variability in the test. I have context, right? Maybe I need to make sure that there's files in a directory before the test runs. Maybe I need to make sure that I have a password for the database, or maybe I need to make sure that there's a DNS lookup that's going to succeed for a particular API host name. So in integration, your code runs in the middle of a bunch of other things, right? I need those other things to be predictable. So that's control. I need to be able to make something succeed when I want. I need to make something fail when I want. And determinism is the flip side of that coin. Every time I run the test, I want it to do the same thing, right? So if you're using clocks or random numbers, those are sacrifices you're making in terms of determinism. So I'm using test isolation to control what's around my code when the code is running, right? And to make sure that every time the code runs, and for every developer or on local and in continuous integration, I want the test to have the same results regardless when it's run and who runs it and where it's run. If it's on Mac or on Windows, those are determinism issues, right? So test isolation can help increase determinism and increase control of the unit test. Now, it's also, I don't know if you guys ever noticed, integrations are sometimes slower than other types of code. They take a long time because they're doing lots of network calls and stuff. If it can be helpful to have your unit test suite run fast, right? So you can imagine an isolated unit test that doesn't really have to run a giant query on a SQL server is going to run faster than if I actually call the database and query 1.5 million rows, right? It's going to be faster, or make a whole bunch of API calls over the network. So you can make your test run faster than the real code when that makes sense. Now, sometimes in integration, you want to test performance, and so you don't want to isolate for speed, but isolation definitely can help improve the speed of your test suite, right? And clarity, of course, this just means when the test fails, I want to know what failed. I want to know that it's the code I care about that failed and not some other thing that's plugged into it, right? So that's so test isolation achieves all these different objectives. So in MUnit, I want to just review a little bit of MUnit anatomy here. An MUnit test, this is one test in the screenshot. It's part of a file called a suite. So in MUnit, you create suites. Suites are files. And then inside that suite, you can create one or more test scopes. And that's what you see on the screen here. This is an Anypoint Studio screenshot. I have not migrated all these slides to Anypoint Code Builder yet. And this is not, I am not blaming Anypoint Code Builder. There's nothing wrong with their MUnit implementation. I just haven't migrated my materials for Code Builder. So this is going to be an Anypoint Studio demo because that's what I prepared. The test, in no matter what editor you're using, is going to have three scopes. So the execution scope is just like a subflow. It's going to, when the test runs, the execution scope is what's going to run. This is the code under test. So you want to use some way to kick off the part of your Mule application that you're trying to test in your execution scope of the test. Now, what you don't want to happen in the execution scope is any assertions. Okay, so assertions in MUnit belong only in the validation scope, not in the behavior scope, and not in the execution scope. And I haven't seen that emphasized enough in the MuleSoft documentation. So assertions only belong in validation, and there's a very good practical reason for that. It's because they don't show the failures properly in the test reports. The validation scope is watching all of your assertions to collect whatever their results are so that it can print them out in your report at the end, right? So you want all your assertions to be in the validations part, and then your behavior scope is how you isolate your unit test. That is the point of the behavior scope, is test isolation, this whole study group, okay? So we're going to spend our time in this study group up there in the behavior scope, and I have a whole code example to show you for that. So I just wanted to give you a little bit of the anatomy of a test. We're going to talk about a particular operation called MUnit. That's something you can add to your behavior scope. And when you use a MUnit operation, you identify a processor. So a processor is the XML element name in your Mule source code of the particular part of your flow that you do not want to actually run. So you're using this MUnit to make sure that when one of your applications runs, one of the steps is not actually executed, right? So I'm going to be doing an example here in Anypoint Studio. And if I have like a batch job and I don't want to actually connect to the SFTP server here and list files, I can use a MUnit so that this flow will actually run, but this one step will be replaced by some code that I control from the test rather than executed for real, right? So we're trying to inject ourselves inside the flow and cut out part of the actual behavior and replace it with something that the test is in control of. And that's what we're going to do here with the MUnit processor. So you put a element name up here, and it's going to look for that somewhere in your application. There's a little bit of nice IDE help here with the pick processor button, and it'll let you kind of look through your code and go find what the different processors are. But just from a coding point of view, this needs to be specifically, this needs to be the element name that's being matched. And then these attribute names are additional specificity. So maybe I don't want to match all of the execute script processors in the whole application. Maybe I just want to do the execute script processor with a particular config ref or something like that. So there's a test design choice you're going to make here of how specific and how brittle you want to make your unit test. So a well-designed unit test, you want it to only fail when something's actually wrong, not just when something unimportant changes in your code, right? So how you match what you're mocking is going to directly influence how brittle or robust your unit test is to future maintenance changes by you or by other developers, right? So you're going to use these attribute names to match something meaningful about your processor. And then there's a control of, okay, instead of actually going off and doing the execute script step, maybe we want this particular hard-coded result to be returned instead, right? So the example on the screen says truncate tables, right? So in the actual application I have here, we have a truncate tables step right here. And it's is this a DB execute script? Or did I change it? Yeah. So it's a DB execute script. You can see it has these attributes, doc name, doc ID. Now, it is possible to use doc ID for your mock matching, and I don't recommend that because it's meant for metadata attachment inside the IDE. Some people will do it if you can't find something better, but you can match any one of these attributes. You want to match on enough to distinguish this particular execute script from any other ones that are in the application, and that's all you need to match on. And the more lenient you are, the less precise you are on the matching, the more robust it'll be to future changes to the application by other developers here. So we're going to match this execute script step with a mock when, and then we can control what comes out of it. And we're going to do that together. I'm going to do a interactive exercise. First, I want to talk about the twin brother of mock when. There's another operation you can add to the behavior section called verify call. So it's a lot like mock when in terms of you use it to match something, and then you're able to count how many times that the code actually does that job. So you want to make sure something gets called. Verify call allows you to not stop it from happening like a mock when, but instead just count how many times it happens, right? So we're going to use those two to accomplish a couple of objectives in a real Mule application. Okay, I'm going to put this into practice. So we have a batch job in our application here, and we're going to, it connects to an SFTP server, and it lists all the files so that you can loop over the files and do a process, right? And we want to make sure that before the list operation happens, we get the database table that we're loading truncated. So we have two objectives for this unit test. We're going to isolate the unit test. Number one, we're going to truncate the table, and we would prefer it if we don't actually connect to our real database and delete all the data out of those tables. That would be rather destructive when my unit test runs, right? So I'd rather mock that. And I just want to make sure that the code tries to truncate, and I don't want the code to encounter an error, but I also don't want it to really go in the database and truncate all the tables, right? So we're going to make that one not happen. And then we're going to list the files, and we're going to make it only get one file. So that way, when the batch job runs, it only runs one record, right? And that allows us to control that during the unit test, this is going to actually truncate the table, get exactly one file, and then process all the rows inside that file, not one record, however many records are in the file that it finds on the server, right? So we're controlling the beginning of this. So I have a unit test kind of already started for this example here. And I've got two tests created. One of them is a test to express that I want to make sure that when you run the batch, it clears the database out, right? And then I have another test that's designed to check that when we insert the patients, all the entries actually get inserted, right? So we're going to start with these objectives. Let me find my objectives again. Make the SFTP list step, return one file, and assert the size variable equals 1. So we're going to use a mock to do that. And we're going to use, let me get rid of that too. I wanted to add all this. So we're going to use the execution scope to run the flow this reload batch flow, okay? So this unit test is called reload batch should clear the database, and it calls the reload batch flow. And since that flow is a scheduled job, that flow doesn't have any input. So this test doesn't need to provide any input. It's just going to run the batch job, right? And we want to make sure that the SFTP list step returns one file. So let's do that first. So we're going to go to the MUnit tools, and there is a mock when processor. I lost my chat, so somebody needs to speak up if the chat has anything, because my windows are I'm getting too many windows. So we're going to add that to
I'm
the
watching
behavior.
for you.
Yeah, thanks a lot. We're going to add a mock when to the behavior step, and I like to describe in my display name what's getting mocked. So SFTP list returns one file. I'll put that in my display name. Just kind of set my intention, and now I'm going to make the code actually do it, right? So we want to set which processor are we going to mock. So I'll go back to my code. I want to mock this one, the one that lists files, right? And that one happens to be a SFTP list, SFTP:list element. I could just type that in, but Anypoint Studio helps a little bit and gives me this pick processor button here, right? Pick processor. And I can see if I go to the reload batch flow, it'll have a kind of a list of all the processors. There's the list operation. So I can double click that one and it'll give me a chance to choose which attributes I want to match. Well, I certainly want to match list files from my SFTP config ref. And I think probably I'll mock if the directory path matches batch demo. That seems good enough. So that's what I'll use. There we go. There we go. And I'll just match those two. And now I've got a mock. So instead of the SFTP list actually being executed, this mock is going to execute. Right. And what I need to do is control what comes back. Now, there's a couple ways to control what comes back here. I'm going to do the easy way and the hard way because sometimes you need both. Okay. The easy way is there's a then return section at the bottom. This controls what mule event comes out of the mock when it runs. So I can control the payload. I can control the attributes. I can control if there's an error, right? And I can even set variables, right? If it was a flow reference or something. Mostly you don't have to do all of those. And mostly I only control what I care the most about. So I can control that what's going to come out of the SFTP should match what happens in the real application. So I ran this application before the session, and I know by running it for real that what comes out is an application Java media type. So the mule event that comes out, the payload, is going to have a value and it's going to have a MIME type. And I went and ran it before and I noticed that it was a Java MIME type. So what SFTP list produces is a Java object, right? And I can use DataWeave in the value section to control what that Java object looks like. So I'm going to use output application Java. And I have I'm looking at my other screen. I'm cheating because I did the work before. It returns an array because it's a list operation. So it's going to give me back a Java linked list or array list. And the items in the list represent files that are in the directory, and those are represented by Java objects, which are hash maps. So this is how we express that. So I want one file, right? One file. And I want it to have a payload because that's what they have, right? Which is going to be whatever it is, right? And it's going to have an attributes, which is going to be an object, okay? And the payload that comes back is going to actually be I want it to be some test data that I've already prepared. So I ended up creating under source test resources, I created a folder called test data SFTP, and I put a few files in there that I want to return. So I'm going to return this p1.json, right? And again, I'm cheating because I ran it once and I looked at what it actually came back with. So I have a reference over here. When you do this on your own, you're going to run the application sometimes in debug or use loggers, and you can see what actually does come from the real SFTP list, and then you can make your mock do that, right? So I'm going to use test data, which is this folder here, slash SFTP, right, slash p1.json. So it's going to go get, I have to use a read URL to go get that off the class path. And when I read it, I need it to be the actual MIME type that MuleSoft's going to see. So I actually have to use this because this is what comes out at runtime, not application JSON, text JSON. So it's going to read this p1.json from the class path, and that will be the payload field of the first object in the array. And the attributes, I care about the file name. So I'm going to use p1.json here too. So we've kind of prepared what's going to come out of the SFTP list operation, right? And I can run this now and see what happens. So I'm going to do that, and look, this is dangerous, right? My actual flow truncates the tables first, right? So I want to be careful before I run it. let's go see what my properties are. Local test.yaml. I have an SFTP port. I want to check the database too. Here's my database config. It uses a real database. So I'm not going to run it yet because I don't want to destroy my whole database yet. Right? So we have to stop this truncate from happening too. Now, there's only one way to stop it from happening. There's not like many choices. You have one choice. If you want to stop it from actually running the execute script, you have to use a mock-when. So sometimes we use a mock-when just to prevent things from happening, right? And this is going to be when database truncate script. There we go. So I'm going to hit this truncate patient and encounter. And that doesn't have much to match on, right? I just want to make sure that if any script runs at all, we're just going to make it not really do anything. Let's see if I had any more that I needed to return. I want to go look at my code too. So my truncate execute script, it doesn't use any kind of target variable. It's just running, and it's going to output an array of numbers, which I guess is how many, whatever the SQL result codes are for each one of the things. I don't care about that result because we never use it, so I'm not even going to put one. You could actually go put a then return down here at the bottom of the mock, right, and have it actually give me back an array of numbers, but I'm not even using that in my test, so I'm just going to leave it alone. So here's the mock-when. We're going to hit the pick processor, and we're just going to pick the truncate and match the config ref and press OK. And now it's matching execute script. Save. So now let's look back at my flow here. It's going to do a bulk insert, and it's going to do 2 bulk inserts. So for this test, I also don't want it to go off to the database and put any data in there, right? So I'm going to mock those as well. One more mock. And I'm going to use this mock very kind of creatively. I'm just going to take all the bulk inserts, period. I don't care what bulk insert it is. I don't want it to really do anything, right? So we're going to go ahead and take this bulk insert, but we'll just say all bulk inserts to the database, period. Doesn't matter which one it is. We're going to mock those out as well. So now it won't actually insert anything. So we've taken the main things that this test does. And what I'm trying to test in this test is that the list operation returns one file, and we make it through here. And then we can check things like, does it insert the right stuff into the database? Now we have control over the batch job. We know what's going to run through it for this test, right? So let me actually rename that one too. Bulk inserts mock. Yeah, there we go. So I've got 3 mocks. Now I haven't put my validation in here yet. So for now, this one is just making sure that reload batch should clear the database, right? So I'm going to add a verify call to make sure that the truncate actually happened. Mock doesn't make sure anything happens. It just makes sure things don't happen and that we can control them, right? Verify call makes sure that things did actually happen. So I want to do the truncate call, and I'm going to pick execute script like that. Pick the config ref, and I'm actually going to put the doc name on this one. I want to make sure that the one that says truncate patient and encounter actually happened. So now the text on that execute is going to matter for this test, and we're going to validate that the number of calls to that is equal to 1. And now we've got a test. So now we should run it and see what happens. So we're not going to SFTP, we're not going to the database, and we're still testing something useful, right? We're testing that the code in the middle of all that does the right thing. And I guess it's still running. Oh, it's still initializing. Come on, Mule, start up the truck.
Ryan,
Boom,
Ryan, how did you get your MUnit over there in your mule palette? I'm probably going to ask the silliest question out of everybody, but I can't seem to get it over there.
Mine automatically came up, but here, let's close it so it's gone. Right? And I want to come back to the error that happened here.
Okay.
Mule unknown. I don't like that an error happened.
I'll let you deal with that. And if you want to
But
answer
but let me
later,
get that. Let me get that open. Ready? So I closed all the MUnit stuff.
Mm-hmm.
Anytime you want something back, you can go Window, Show View, Other, and that gives you a list of all of the different views in Anypoint Studio. And then under MuleSoft, there's an MUnit, and you can press Open. And if it doesn't go in the right place, let's say it went over here, you can drag and drop them around. So you can always get it back. There's a shortcut too. You can always go up to this little perspective at the top right click, reset, and it puts all of the windows, the views back where MuleSoft automatically puts them. So if you lose stuff, you can get it back. Right, I'm going to close CurryTech here. So I think it ran both tests. So I'm not actually sure that error I got is related to the test I wanted to run. So I just want this one to run this one test. Let's see if I can get it to just run the one and make sure whether that test is doing what I want. Now you see how specifically I designed this test. All this test is for is making sure that the database gets cleared. And it's not checking anything else about my batch, right? So if we ever get a failure in this test, we know exactly what's wrong, not just something's wrong, right? Specifically, we're not clearing our database first, right? And you want to try to, I like to design my MUnit tests to be specific like that. They check things I care about. Each test checks a thing that I care about. And the next test checks something else that I care about, and they don't check each other, right? So if something else that I care about isn't done, then I need to design that test. So like, here's one, insert patients, should insert all entries. Now, I'm going to save that one. I think I've achieved, let me check and see my objectives here before. I think I actually have a couple more slides for you guys. Yeah. So this one makes sure we get one file out and that we get a truncated script. So I'm going to slow down and see what any questions about what we just did before I kind of move and add more to it. Good. Okay. Well, let's add more to it. So I want to add one more isolation tool to the mix called Spy. So Spy has a different purpose than mock and verify. Spy allows you to let your test find out things it needs to know, right? About how the code ran already. So Spy captures information while the flow is running so that we can then use it to see if the flow did the right thing. So you can use it to grab data in the middle of your flow. You can use it to find out that things, you don't want to maybe test something until after it's finished. Spy lets you do both of those things. So we're going to go use that to make sure that this batch job inserts the right patients into the database and that we've inserted the correct encounters into the database. Okay. So, so I have another little test kind of ready to go. It runs the same flow that we just ran in the other test, but this time it checks, one of the things it checks is that the patient count is equal to 20, right? So how am I going to do that? Let's go look at our sample files. P1. Does this have patients in it? It looks like it does. These are big old patients. These are FHIR patients. FHIR is a pretty complicated JSON format that they use in healthcare. I wonder if I have a entry array. Yeah. So I should be able to shrink that one. Yeah, there it is. So here's the entries in this JSON, and they're hundreds and hundreds of lines long. And we want to, how do I show you guys that there's exactly 20 of them? It's a very big fire result here I used. Well, I'm going to ask you to trust me, I think, on that one, that there's 20 patients in there. Let me just make sure that's the right file too. Yeah. Okay. Well, there's 20 patients in this p1.json file. I'm not going to save it. And so I want to make sure that when this batch runs, all 20 of those get inserted, right? So how am I going to check that? Well, that's what SPY is for. So for the second flow, and this is for the second test, we still need to mock the same things we did in the first test, right? We don't want my second test to delete all the data in the database either, so I still need to mock the truncate script, and I still only want one file, so I still need this one as well. I still need the SFTP list. So you could copy these and paste them, and for only 2 tests, that's what I'm going to do. But good news, everybody, if you wanted to reuse these mocks, you can stick them in a subflow, and that works just fine, right? So it is okay to use subflows for your mocking. So now I've got the database truncate mocked. I've got the SFTP list mocked. And now I need to capture what patients are being inserted on this bulk insert step. Now let's take a look at a few things. It's going to, the way this batch runs, it runs on a list of files. So we only have one file coming back from the list, which means the entire file is what's being processed inside this batch step, right? So it's going to grab some data out of the file. It's going to transform it, all this transformation stuff, and then it's going to do a bulk insert of all the rows that were in the file in a single insert into the database. So I want to know that what this insert statement receives is an array of objects that have all these field names set properly. See that? I need to count the array of objects that arrives at this bulk insert step. So that's a great chance to use a SPY. So we're going to add a SPY here. Boop. And what we want to do is match the bulk insert statement that happens in the first step of the batch job. And that would be, here's the batch step, here's the bulk insert statement, insert patients, right? So I'm going to SPY on the insert patient step. Now, I actually don't want them to get inserted either. So sometimes you have to do both a SPY and a mock if you want to stop it from happening. All the SPY does is watch what does happen. So I'm going to finish the SPY. We still need a mock to stop it from actually inserting. Okay. So what I want to do is before the Mule event starts processing, I want to capture what the input was. And what do I want to do with it? I'm going to want to put it in somewhere that I can grab it and use it. I need to be able to get to that information in my validation step. So if I'm going to count how many patients were inserted, I'm going to need a variable called and I've named it DB params, and I want to know that that has 20 items in it, right? So I need to somehow in here set a variable. Now, so I'm not going to actually do it this way, but I'm going to show you what you might think of doing and then tell you why you don't want to do that. We could set the variable right here, right? And this is DB params, and the variable is, and we're going to set that equal to the payload, right? We could do that, but it's not going to work, right? Because all this does is set a variable on the Mule event that's sitting here inside the batch job. It doesn't make it available. Batch jobs are asynchronous, right? It doesn't make it available to my test, right? So if I want it to be available to my test, I need to capture that information and park it somewhere and then go back and get it. Plus, here's the other problem. Batch jobs are asynchronous. So my test is going to be finished before we ever make it to the bulk insert step, right? So another thing SPY is great at is waiting for things to happen. So I'm going to show you that pattern. So instead of setting a variable here, you don't want to set a variable. Instead of setting a variable, you want to use a special tool in MUnit tools called queue. So what I'm going to do is right before the insert happens, I'm going to grab the payload and put it in a queue like this. This is going to be db params and its payload. And I'm going to make a queue name called db params. So I just made up a new queue, and we're going to put the payload right before the database insert happens into the queue. Now, what I can do is in my execution step, I can dequeue. And that dequeue is going to block until something shows up in the queue, right? So this makes my execution of my test have to wait until the insert actually happens, right? This is how you do asynchronous testing in Mule. So I'm going to do db params, and I'm going to wait, I don't know, 1 minute. You can tell it how long to wait, right? So it's going to wait for a whole minute, up to a minute, which is going to make your test slow if it never happens. But I want to wait for up to a minute to see, so that the test only continues at this point if the data has already been inserted into the queue, which happens because of the SPI. Okay. What is this one for? Why do I want that? I'm just checking that. Okay, got it. There's another insert happening here at the end for encounters. Now, this test doesn't actually care about encounters. Right. Very good. All right. All right, what we're going to do next is we need to stop the actual insert from happening in the real database, right? So we've now captured the input to the insert, but we haven't stopped it from going to the database yet. So we're going to have to also put a mock in here. So I'm going to add a mock for the same bulk insert like this. Files. And here's the bulk insert. And let's see what it returns. Here's the output. It returns an array of number. And as far as I can tell, it's not using that. Type, reason, code, location, class, period. I don't see it using that. Let's see if it's using what the output is. It might be using it. I haven't looked at this code in a while. So because it might be using the output, I'm actually going to mock the result to be an array of numbers, right? Which is going to be a whole bunch of zeros because it worked fine. So we're going to mock when the bulk insert patience happens. I'm going to pick the processor. Here's the insert patience. Ta-da. Boom, boom. And when it returns, we're going to return a payload of an array. I'm just going to do it like this. 1 to 20. I need 20 zeros, right? Map 0. So now I'm going to get 20 zeros in an array. And this needs to be output application Java because that's what comes back. And there we go. So I'm telling it to give me 20 success values back from the insert statements that went to the database, right? There we go. So now it won't actually go to the database. And it's going to validate that when db params come out, I need to put that in I need the variable name to be db params, right? So on my dequeue, whatever comes out of the queue, it needs to know that what went into the queue, which is the payload that went to the bulk insert, is 20 long, right? So when I dequeue it, I need to dequeue it into a variable called db params. There we go. I dodged a bullet there. It would have failed. So let's run that one. And you kind of see what the SPI is doing now, right? So run that test. SPIs are cool, right? What'd you do at work today? Oh, I made a SPI. You guys are in espionage. And, oh, I got a failure. Let's see what happened. Expected 20 patients to be inserted. Expected 20 as number but got null. So let's see what I did wrong here. We dequeued the DB params into the payload. And here we queued the payload into DB params. That looks fine. We did it into the variable DB params. And it says I got null. So what's nice about this, I don't know what happened. So I'm going to find out what happened. Right? I'm going to put a logger and a breakpoint. And we're going to debug the test. I love this part of MUnit. I'm going to watch the logs run first. It's going to run the batch. I'm expecting it to just go to the end, and we'll just be sitting in the test. All right, we made it here, and it's running the test. Let's see. Print variables after batch. So it ran the whole batch. Let's see. Did it run the batch? Created instance. Starting loading phase. 1 records were loaded. All right. So if I step from DQ, why does it now go here? It shouldn't go here. It should have already been here. So I get to the logger. What it looks like is it DQ'd too early. It DQ'd before the queue happened. That was weird. So I'm going to hit stop. I could try to extend the timeout on the DQ to 2 minutes. I didn't feel like it was that slow though. So let's do that one more time and see why it went that slow, because I did not expect it to. It looked like it didn't go on to the batch until I so if I put I'm going to put the breakpoint here. Oops. Add breakpoint and remove this breakpoint. I don't want it to wait for the batch. So it finished the whole batch. It ran the batch. Here's the queue. Here's the DQ. And the test is still executing, which is good. It's waiting the 2 minutes. Finished processing all records. So as far as I know, the data should be in the queue right now. Wonder if I just didn't wait long enough. Seems like it's timing out though, because it's sitting here. It's going to time out for 2 minutes. I wonder if I named the queue wrong. Queue name is DB params. This queue name is also DB params. Seems like it's still going. Two minutes is a long time. So it must be timing out on my DQ, which I don't know why it's doing that. I'll put a breakpoint there too. Save. Let me stop this one. I want to see it actually work before we end this whole lesson part. Why is this? It seems like it just completely. It seems like I don't know if it's over. All right, let's debug that one more time. I think I killed it. Now runs 1 of 0. There we go. And here's the console. It hasn't started the batch yet. You see, there we go. Initializing. It's being super slow. My computer's usually a lot faster on Mule. All right, I made it to the queue first, and then I continued. Then I made it to the bulk insert, and then I continued. Then I made it to the logger. And when I made it here, now I have a variable here. Good, but it's holding null. So whatever it found in the queue didn't match, right? And I don't know why it didn't do that. So when I tried the example, it did. Just putting payload in the queue. Oh, I think I know why. Right. Let's go back to my batch. So when I do the bulk insert, the input parameters are the payload, right? I do this transform here. This is my payload. So I'm setting all these parameters. F name, M name, L name. All right, good. And then why is it giving me that? I still have a breakpoint there. So we need to see what the payload is at that point. Debug. I showed you the design, but I didn't show you the green test. Let's get there anyway. Want to see what happens in my bulk insert step. All right, we got to the queue step, which is before it gets to the database. So right when I get here, my payload is null. It shows my payload is null before I even got there. That's weird. So I'm going to continue. And now when I get to this point, my payload is also null. So I think what happened is this transform came with null. And that I haven't figured out why that happened. So what I'm going to do, because I'm trying to show the mocking, is it has to do with the fact that the batch itself has a bug. I'll do a separate transform in my batch just to show the mocking part, and then I'll have to come back and figure out why my file didn't have what I thought. That's a pretty complex transformation there. For some reason, it didn't come out with what I wanted. I'm just going to add another transform after it, right? And this is going to be fake parameters, right? And the parameters need to end up being a array, right, of all the items in there. So I'm going to do 1 to 20, map a bunch of fields. F name, for example, Bob there. Because I would like to see the mocking actually capture that. Let's do that one more time. Insert patients, debug. And then, in my real project, I would come back and figure out why my transformation was giving me a null. Right? That was something wrong with my input data. Actually, I think I know why it did. While that's running, I'm going to go check it out. Let's check my other mock. Here's my mock for the list. And this returns whatever's in p1.json. So that's probably what didn't come back with good data. So I made it to this DB param step, and now my payload is size 20. So when I continue, it's going to capture that 20. It's going to put it in the queue, right? And when I get to this step now, I'm going to have a batch result, and I'm also going to have a variable, right, named DB params, right, which is a bunch of items, right? So this is what was sent to the database, and it's in the variable DB params because it came out of the queue, right? It was captured by the spy. We took it out of the queue. We put it in the variable DB params here with the target variable, and that way everything's set. So when we get to the validation scope, we're actually going to be able to check it, right? And if I continue, finally, I'm going to get a green, right? So what I had to debug there is something is wrong in this test with whatever comes out of this SFTP, and I have to go debug my transformation, right? But I wanted to show you the isolation in this lesson. So we got Qs, we got the SPY, we got a mock win. I think there was one more twist I wanted to show you guys about mocks, but I'm 8 minutes over. So what I'm probably going to have to do is I'm going to do another study group sometime. RJ can stick me on the schedule about resilience tests. So what I didn't really show you is basically simulating explosions, like when stuff breaks. The mock win processor has this great then return feature down here, and you can kind of put an error here, and everybody ends up tripping over their shoelaces with this error field here because it's not very powerful. You can't really make realistic errors, right, for your application. So if I wanted to test a database connection refused, or an SSL certificate error, or things that happen in production, these errors just don't cut. They don't cut it. They're not very good. So there's this beautiful thing at the bottom called then call, and I can show you guys some patterns on making bad stuff happen for you, so that you can test what does your application do when the bad stuff happens. So that'll have to be another study group, but it is definitely still on the same topic as test isolation, right? Because test isolation has to do with controlling and what the code is doing, the context, the circumstances around your code when it's running. So sometimes what we want to control is we want to simulate bad things, right? So we'll save that for a future study group. But I think I better hand it back to RJ. This is my invitation to you. Go make some quality code.
That was awesome. Yeah. I appreciate you showing all that. Just to give you everybody in the room a brief idea of how new that was to me. My struggle, the reason I popped in and asked, where's the MUnit? I can't get it figured out, was because I didn't even know that you're supposed to right click over there on the source and test an MUnit and activate it over there in the Project Explorer. I didn't know that. So
yeah,
I started following along after that, and now I've got some stuff to be checking out for sure.
That's why I like to get out of the slides. If you're just doing slides, it all seems easy, and then you go to do it, and step one, it's like, how do I do step one?
That
so
was
you
it,
get
man.
into the editor together, and you can see each one of the things the person does.
I'm looking at your studio, and I'm like, his studio looks different than mine. What is he doing? And I'm like trying to figure it out, and I'm Google searching, getting nothing back. So that's why I jumped in. I appreciate you answering that. Didn't mean to interrupt. And
that was great.
I'm glad that we can do that anyway, obviously. But yeah, I had to click on the source test MUnit over there in the Package Explorer. Had no idea. Now we know. Does anybody else have any questions? Probably way beyond my question. And Philip came in. Nazi Meringue, you've been here a couple times, and I got you on LinkedIn. I hope I'm saying your name right. I'm glad that I have you on LinkedIn. I'll keep up with you on there. And Marius came in.
Hi.
Glad to have y'all. The other thing that I was going to say too, not to put you on the spot, but if you did want to do that resilience testing, we have availability like next week even. But I don't know. You may not be available. If you're not available, it's no worries.
Well, I don't know. I don't like to do the same topic 2 weeks straight. I think we had somebody. We have somebody who might be able to do the 7th or the 14th. I think. Did we get a topic? Let me go look at the topic for Shravan. Let's go see that the last Shravan. I met Shravan. So I went to Dreamforce a couple weeks ago, guys. And I met. I've been in a couple of meetups with Shravan Narella. And he's from I don't know what state he's from, but he's not from California either. Both of us flew in and we bumped into each other. I've been a lot of the AI stuff that MuleSoft's doing around MCP and A to A. So he's been doing a lot of the agent fabric and MCP stuff. I thought it'd be nice to see a fresh face, and plus he's further ahead than I am on some of it. So might be nice to see somebody who's focusing in on I think A to A, probably like a beginner agent to agent type of a study group. would be good. We didn't nail it down, but we're looking at kind of a more cutting edge MuleSoft AI topic with Shravan Narella, and he's already agreed to do it. We just haven't nailed him down, but I'll see if we can do the 7th for that, and then I could probably bring this back
Awesome.
on the 14th if we can't. I thought we had Diane on deck for the 14th though.
No, she's going to be out of town.
Oh, that's right. She's the end of the month.
She's gone.
She's Black Friday.
That's right. That's right. But yeah, that makes sense. Yeah, you don't want to do the same topic totally. And usually I have a slide in here, everybody, to kind of give you a sneak peek on what next week will be about. Ryan just said it right there. So there it is. I didn't really know that for sure. So that's brand new info. Watch your email on Monday and you'll get a confirmed, this is what we're going to be doing kind of thing. So
yeah. And if anybody's into the resilience tests, like you're excited about it, send us some kind of notes or something and we can accelerate the process.
Makes sense. That's a good call. Well, if nobody has any questions, I'm going to go ahead and thank everybody for coming, and I'll stop the recording. Just real quick too, if anybody doesn't know, you can hop over to the Integration Quest website. There's our study groups on there, and we've even got where the little arrows pointing classes for y'all to check out. Go check it out if anybody didn't know that. And we appreciate you all coming. Thank you so much. I'm going to stop the recording. If anybody wants to chit chat, we can.